Hi everyone. We'll be giving a demo on MiniNDN. So as Alex already said that MiniNDN is based on MiniNet. So it's a fork of MiniNet. So to get the instructions on how to install and getting started, you should get all the information you need here. MiniNDN.memphis.edu and you can just go to our GitHub. So the GitHub link is also in the website, MiniNet website, MiniNDN website. So these are the prerequisites of the MiniNDN. You need to have NFD, which is the forwarding daemon for NDN, and NLSR, which is a linked state routing protocol for NDN, and you also need to have the NDN tools if you want to play around, if you want to have different nodes interacting with each other, like with different kind of NDN tools like NDN ping and ping server. And you also need to have MiniNet installed. And
but there's so I guess before we launch into the sort of getting everything started, is everybody here at least vaguely familiar with what MiniNDN does, or should we give a kind of a 1,000-foot view of that? Okay, so sort of one of the principal problems when testing a networking infrastructure is how do you actually show that it works? You have one approach, which is to get the test bed. You build an actual network of actual computers and you tunnel them together or something. But MiniNDN is the other approach where you just emulate them all on one computer. And it uses MiniNet, which allows you to build a virtual network infrastructure on your own computer by faking devices. I think it only works on Linux because it uses a special kernel module, but anyway, it allows you to construct topologies of nodes and you can impose, I think, delays, and I think if you want to dig into it, there are ways to impose timeouts and sort of loss rates for each of the connections, which makes it a really good tool for actually investigating the effects that different apps will have on a network without actually having to acquire resources to set up a hardware network. So it's very convenient. We use it a lot for in-home development of NLSR, among other things. It's even incorporated into our integration testing because it's actually really useful for deriving performance from the network or getting metrics about that performance. And so we do have an installer script that does all of this hard work of getting all the prerequisites for you, but you are a bit at the mercy of what is in your repos, so you may still have to go behind the scenes and get all these things installed, but ultimately it's just a forked version of MiniNet, so if you can get MiniNet running, you can probably get MiniNDN running. So
yeah, given that you have all the NDN prerequisites installed.
Right.
Yeah.
So I think we can...
Yeah, right. So like if you have all the prerequisites installed, then you can just use, then you can just fork this MiniNDN repo, and then I use this script -i option, which will just install the MiniNDN.
Do you want to open the VirtualBox and do that live real quick?
Yeah, right.
Just to show what it would...
Yeah, so for example, I already have it installed, so that's... So yeah, this is the one you will be using if you have, yeah.
Okay, I see that you're using Vagrant. So do you have any helper scripts like Vagrant file to actually simplify installation?
I don't know. I don't think so.
Planning to make it?
Yeah, I think it would definitely be helpful. So we're looking into it. The main developer is not at the conference, but we will get a file. I think it would make it more convenient to test. In fact, that's what I've done. I have a pre-configured VM image that I just copy around whenever I need to toy with it. So a Vagrant file would be pretty convenient.
So yeah, so basically this is the command you will use if you have everything installed and you just want to install MiniNDN. But this one is more convenient in that so this one is going to install everything for you from the NDN prerequisites to MiniNet to MiniNDN. It is going to install everything for you. This command, since it is going to take a while because
you have to compile all the prerequisites. So kind of doing that live would be a little laborious, but we've already done that. You know, we've baked the cake ahead of time, so
Yeah.
we have everything ready for you here.
Yeah. So after you have installed MiniNet, then you can simply do this command. Sudo MiniNDN, which will create the host, the nodes. The nodes are basically the bash processes, and they are when you try to link to host, it's basically Ethernet, virtual Ethernet pair.
Yeah, it's emulating Ethernet, and MiniNet requires sudo access. So I guess if you're working on a sort of school-provided computer, like maybe a mainframe or a server somewhere, that might be a problem. We're looking into removing sudo access, but there's some problems about providing temporary home directories for each of the nodes to operate out of. But it is something we're working on. But at this point, you do need sudo.
No, it's MiniNet. It's impossible to run without sudo.
Yeah, we've looked into kind of mitigating the amount of sudo you need, but yeah, I don't think there's a way around it at this point.
With Docker, which has issues. So for Docker, you either run Docker in the highly privileged mode, or you give like this ton different privileges in order to actually run MiniNet in any way.
It's a little inconvenient in it, but it does, you know, it's part and parcel of it. So once when you run this, does it wait any time for? No. So it just runs. It sets up the topology, and then you're given this MiniNDN shell to work from, and it allows you to issue commands to the individual hosts and to inspect their statuses. And it's basically just like a sort of meta shell where you can select one of the nodes and issue commands to them, sort of like you're at the shell for each of those individually. In general, we don't interact with it from this point. You can actually run experiments. So.
Right. Yeah. So here we did not specify the topology file. Here you can also specify the topology file.
So it
if you
just
do not
picked a default one.
Right. Yeah. So if you do not specify anything, so it is just going to pick the default one. So
so I think the default topology. Yeah.
It's just a 4-node topology. So yeah.
Let me have a look real quick. I don't remember off the top of my head.
So yeah. So it is in this folder. Yeah.
Oh yeah, it does say the topology. Yeah, so I think it's.
So yeah. I mean.
I think it's a sort of diamond topology.
So all the MiniNet command also works in MiniNDN. So this is net is in like MiniNet command, which will show you the topology of this network. So yeah, this is the topology basically. So yeah, this is the format of the topology file on the right side of the terminal. So here we have like 4 nodes, and here is the links. So here we specify that like which link is connected to which link, and here we have the delay, and you can also specify the bandwidth here.
Is there chalk I can? Oh yeah. So I think I can draw the topology here just so everybody can have a sort of visualization of what that looks like. So we've got so AB. What is it? AB, then A to B, then also to C, then B to D, right? So then B to D. So this is the default topology that it'll give you if you don't specify one, which is fine. Generally, we use a couple topologies. I think we've got one modeling a setup at UCLA. We also have one that models the test bed. So we kind of have a couple defaults that come pre-installed. They come pre-installed, right? Yeah. They come pre-installed when you install MiniNDN, so you can see how different things behave. And so you might be thinking that if you get a bunch of different nodes installed or emulated on one topology, you might have this problem where you kind of don't have enough resources. And recently, to address that problem, we incorporated features from the cluster edition of MiniNet, which actually allows you to distribute the hosts around different nodes, physical nodes. So you can kind of layer the two systems. So you might even want to use like the NDN testbed to create a larger fake testbed using MiniNDN. And the way that works is basically by SSH commands, and you have to set it up ahead of time. But it does work pretty well. We've done some preliminary testing with the cluster edition, as we call it, and it works very well. It behaves very high performance. So if you want to show the experiments.
Right. Yeah, so yeah, like each of these nodes, so when you run like MiniNDN,
yeah.
so each of these nodes will run an NFD instance.
And it basically works by isolating each of them. I think you can specify a working directory instead of temp. So if you have some kind of permissions problems with a server or something, you can. I don't know why you would if you've got sudo, but you know, if you do, you can specify a working directory so you can actually run multiple different instances of multiple different sort of experiments of MiniNDN if you so desire.
So yeah, by default, the working directory is a /temp. So as you can see that all our like NFT instance and endless instances are under the like /temp, and then the name of the node and then the configuration file for the particular program we are running.
Yeah, so I think we should show them what an experiment looks like, maybe the convergence one. Yeah. So if you're at this, you can do the Control D or you can exit or whatever.
Yeah. So like to quit from, like you can just type quit.
I remember there was a topology visualizer or like a topology creator.
Yeah, I think it's MiniNDN edit.
Right.
Yeah, we should show that before we get too much into the experiments, just to show if you can play around with it.
The GUI?
Oh, yeah. And then that, it's an X redirect, okay. Yeah, so now just run MiniNDN edit and it should pop up. You probably need to run it as sudo, and it's not, it's just, there's no dash, it's just sudo MiniNDN edit.
Edit?
Yeah. There we go, okay, so. Yeah, okay, cool. So,
maybe we can show, I don't know how to do this.
Well, I don't really know either.
So yeah, so here's the host. You can click on it and maybe like put the host here.
Can we maybe zoom in on this a little? No, we can't. Well, we can't zoom in on this, but anyway, it's a bit like a little drag and drop thing. You can drop hosts there, and you can click all of the hosts, and you can drag lines together to create them or to link them together. And at the end, there's that little button in the bottom. You click generate, and it should ask you.
So yeah, then like in the link, you can specify the bandwidth, delay, and the loss in this link.
Yeah. And then at the end, you just click generate down here. It's a pretty small button, but then it tells you template file generated successfully. But anyway, you can click save here, and that will, you can open this and specify where it should go, and then you can use that, specify that on the MiniNDN command line when you run it.
Can you import or like open the existing topologies, or is it a different format?
I'm not sure. Let's see.
Like for example, it would be cool to see this default topology.
Oh yeah, that would be. It's user local. User local. Oh, it's not the same file extension, but they should work. Go ahead and click on that. Maybe not.
Okay, point for improvement.
Yeah, point for improvement. So you can't import existing topologies, at least not the ones that come with MiniNDN, but you can use this to create topologies. So that's definitely something that we should work on. So yeah, like if you want to, it comes with a variety of experiments that we use in-house for integration testing when we change NLSR. So the basic one is the Convergence Test, and what that does is it sets up your topology and starts NFD and NLSR on each node, and then gives the network some time to reach convergence where each node knows about and is able to route to the other nodes in the network. And usually you would use that as a jumping off point for other experiments. So let's go ahead and show them that.
Experiment?
I don't remember. Yeah, dash dash. Yeah, so the way that you get that is with dash dash experiment.
Yes, no, oh yeah. So, there's another thing I want to talk about is so like after you run the MiniNDN and the MiniNet like creates this virtual host ABCD, then you can like probe into in each of the nodes. For example, like if you want to see the status, you can see the status of each of the node.
Yeah.
So, yeah.
And the way that you do that is simply by typing the node's name
Yeah.
as a prefix before you type the command that you want. So if you
Right.
want to see, you know, the fib of A, you would just type A NFDC fib. It's just sort of the normal NFDC command, but you prefix it with the node's name. So if you've got a node that's maybe like FU Berlin, then you would type FUB and then NFDC fib.
So yeah, you can also see the status of in a lesser status of each of the node.
And in this situation, you can see that the network does appear to have converged based on the topology we've got here. You've got all of the routes and or the adjacency LSAs that you can see. So you can use this to inspect, especially if you're running an experiment and something doesn't seem to be working right. This is a really good way to poke into the internals of the network without having to go hunt around SSH logs and stuff like that and trying to coordinate everything because it's all just locally on your computer.
So another thing you can do is you can export the home directory of each of the node, and then you can in a terminal. Then you can directly do the like NFT. You can directly see the status of that node. So for example,
which is to say, if you do want to go hunting around to each of the nodes, you can still do that. It's just
for example,
a directory created for each of the nodes. You can go CD to them just like any other directory. And
yeah. So for example, like I can just like export the like working directory of A is as a home directory. Then I should be able to see that.
yeah, you closed MiniNDN.
Right.
So I think in a couple minutes we should start like an experiment file. Yeah, get a little bit of live coding done.
So all instances of NFD are sharing the same configuration file?
No, and the reason that is because we create these separate home directories, temp A, temp B, temp C, whatever, and then the MiniNDN actually has a bit of a configuration generator. So it uses that topology file that you specify to explain how each of the NFD consts should look, and then it copies each of those into each node's home directory, and when it starts NFD, it actually passes that configuration file as a parameter to NFD so that each of them is running off of a separate configuration file. And it does the same thing for NLSR to generate separate configurations for each one of them. So it's all done automatically. All you have to do is provide the topology file, and you can generate that with the visual interface to get that in a pretty simple way.
So that one is just a home folder. It's not like an entire file system.
Yeah, it's basically just emulating a home folder.
So yeah, you can export that the home folder, and you should be able to access that node right from a terminal.
Which is more or less what the MiniNDN shell is doing when you type A
right,
NFDC status. It's just kind of faking the home for that command.
Right. So we can run a like ping server on A.
You probably need to background it.
Okay, so there is a trick. You can do what you're trying to do, like add in ampersand, but you can also run extern. So that is like in MiniNet documentation. So A extern, which will start the terminal,
right.
and then B extern, and like have two windows.
Right, that also you can do, right? So you can write like X term, then like A's terminal will pop up, then you can directly do, yeah, right.
So maybe we haven't given the network enough time to converge.
So basically here we are running a ping server on A node, and B will be pinging this prefix like 5 times.
Yeah, but we haven't given the network enough time to converge, so I think
that's
we
why,
need to. Yeah, we need. That's a quirk of NLSR. It works sort of on periodic intervals, so when things change, it can take a little bit of time for the changes to propagate, which is part of the reason that most of the experiments that ship with MiniNDN have a little bit of a lag time built into them to give everything a time to propagate through the network.
But this is only for node topology.
Yeah, the thing is NLSR works kind of on sort of second level intervals, so it can take a little bit of time. If you catch it right after sort of routing table calculation, you can be stuck for a while.
On prefix, it should be like NDN.
Yeah,
Here?
yeah, go ahead and try that to NDN/NDN.
And those prefixes are configured where? Or that would be part of the scenario that you're defining?
Yeah, generally you would. So the experiments are just Python scripts, and so we should probably shift gears to that. The experiments are just Python scripts that you run, and basically the experiment is just inherited from a class that we provide through MiniNDN, and you can define. It's got sort of setup, execute, and tear down methods that you override to do whatever you like. Yeah. So here's one that we just I think whipped up real quick. So this is the base convergence experiment that comes with MiniNDN, and basically all this does is it sets up the topology, waits some time, and then checks to see if convergence has occurred, which is just a matter of hunting through each of the nodes' fibs and making sure everything looks right from there. So what you don't see here is that part of the setup is that there is a wait time, and you can change that wait time on the command line. So if you need more time, if you've got a really big topology and you're not on a particularly fast computer, you might want to increase the convergence time to give the network enough time to emulate all of the interactions and such. So,
And I think, yeah, you need to have your experiment script inside this experiment folder.
yeah, it's a little clumsy to write your own experiment, but once you get it, it's actually fairly simple. You just have to kind of put it into the same directory as the MiniNDN source, but you can specify it from the command line. So, but if you're just trying to run it from the command line without any sort of specification, it needs to be in the MiniNDN source tree when you run that install script.
So here will be
Question about previous things. So where the name /NDN/A sites /A comes from? Is it defined in this topology configuration?
No, it's a well, kind of. So it generates these names based on the topology that you give, but it also does some extensions to them as a way to generate everything, if I'm not mistaken. Or I want to cat that. Yeah, so when you select one of these things, when you write a topology, it will append -site to them in order to make, I can't remember exactly why. It's been a while.
Topology file again. I mean this default one.
Yeah, go ahead and cat the topology file on the terminal. Or edit it.
like something like this, yeah. Like, no, this is a different one, but...
Yeah, so this is a topology file that we've written to go along with this experiment, but as the node name is always the first on the line under this section, and then what we've got there is
And so the result in the names that will be assigned by NLSR or something would be /ndn/site node name / again node name.
Yeah, if I'm not mistaken, I haven't.
Node name dash site.
Yeah. Yeah, go into one of the temp directories and let's look at the nlsr.conf file for one of the nodes.
So here, yeah.
Yeah, so yeah, you can see that's right, Alex. Thanks for that. The way NLSR works is it needs to assign each router a sort of name in order to make everything routable. And so the way that's accomplished is by taking the node's name and then appending site to it. That's just the convention is when using NLSR, you have your network, which is generally NDN, and then maybe you have a region, and then you have the site, which is the sort of the local building, the premises. And so we emulate that. We don't need to, but we emulate that naming convention here by appending site to the node name that you specify in the MiniNDN topology file.
So like here is the like prefix. It is going to advertise like this particular node.
Yeah.
Yeah. So like prefix /
And that's a little bit more in terms of NLSR's functionality, but as you can see, it does pre-configure everything. It generates it based on your topology file. So when you run it, it will automatically advertise the prefix for this site.
Okay, follow-up question to this. So now I got where this prefix is coming from, but in many applications, this is not the prefix that application wants to advertise. What would be the mechanism to, from kind of the script or from the application, to ask NLSR to advertise some prefixes?
So there's a command line tool, NLSRC, which allows you to advertise prefixes arbitrarily into the routing system. So if you wanted to test your application using MiniNDN, you would need to write a little bit of a glue script after everything runs in the experiment file that you're writing for MiniNDN to construct your topology and set up all of the necessary programs or whatever for your own uses. You would have to then go as an intermediary and run NLSRC to insert at each of the node stations all of the prefixes that you want. But that can all be done on the command line and in that Python experiment file. So,
what about the prefix readvertise function that we have added recently? Is that can work inside the?
Yeah, you can get that working. It does require a little bit of key acrobatics, but you can get it working. I've gotten it working a couple times for integration testing purposes, and also when I was developing that feature, I had to use MiniNDN to make sure it all worked because I couldn't exactly take the test bed for my own.
Okay, so I think that should be another point for the soon-to-be simplified operation.
Yeah. Getting auto prefix propagation and readvertise to work it's a little convoluted. And
I mean, for the MiniNDN, we can always generate certificates and like pre-install them, so it should not require too much acrobatics.
Yeah, well, at this point, MiniNDN is generally used to represent like a routable network, and in the situation of like auto prefix, it's usually a client to hub. So we haven't extended it out to simulate like client to hub interactions, but that's something we can do in the future to make it a little bit easier to simulate sort of edge of the network interactions.
Okay, and a little bit of weird question. So you mentioned NLSRC, which you can modify the runtime configuration of NLSR. Does it also save that runtime configuration as a config file, or it doesn't affect the config file?
No, it doesn't affect the configuration file. As I understand, when you run MiniNDN, it will generate that configuration anew each time. So
Okay, maybe it's beyond MiniNDN. It's just about NLSR.
No, it doesn't. That's all runtime specific. When you rerun NLSR, it won't preserve.
Do we have a plan to have ability to save the config?
That might be a good idea. Yeah, I think it's on the table. We're extending NLSRC a lot these days, so I think that's something to think about. Make it a little bit easier to kind of incrementally revise your configuration toward the state that you want it to be in. So let's go ahead and show the experiment file here.
So this is basically the convergence experiment. So here in the run function, we are not really doing anything. So the only thing we are experimenting is the check convergence. So we have function defined whether endless are converged in this topology or not.
Yeah, so let's go ahead and open the original experiment file because it exposes some other methods that the convergence one doesn't actually use. Yeah, so generally speaking, when you are writing your own experiment, you will inherit from this class, and the way that it runs the experiment sort of counterintuitively is by calling start, and what start does is it calls setup and then it calls run. So whatever you need to do to insert prefixes for your application to work, you would put that into, you would override setup and you would put those commands into setup, and then whatever actually needs to happen for your experiment to run, you would put into run. And the reason that you don't really need to do too much about convergence is because that's part of the base experiment class. So provided that you're looking for convergence or you're looking for routability for dynamic routing, you would not have to do anything extra to get that in your experiments.
So how many different examples of experiments we have, beyond this check and convergence?
So we have a failure experiment, then most connected node failure, convergence
Yeah, so
experiment.
yeah, I'll explain what they do. So you've got a most connected node where it will pick the most connected node out of your topology. In this case, it would be A, and it will turn that node off. It will simulate a failure in the network of that node, and then it will wait some time for the network to figure out that the failure has occurred, and then it will bring this node back on, and then it will test if the network recovers from the failure. And we have a couple of sort of variations on that one. We do have one that will fail multiple nodes, and it does that one randomly. So if you have a huge topology and you want to simulate just sort of intermittent failures at your nodes, you can build a topology and run that experiment, and it will randomly pluck nodes from your topology to cause failures in for certain amounts of time, and then after that time elapses, it will turn them back on, and it will see if your application recovers. And you can inherit, and in each of these you can inherit and modify the parent methods so you can extend the functionality in a lightweight way.
And what is the kind of output of the experiment? Like how you visualize or see and understand the result of the simulation?
So generally it just prints it out to the MiniNDN window, but what I have found personally to be more useful is to output the results of each, write your own experiment file and to output those results into a log file in that node's home directory, and then probably after the fact to use another script to parse your node's logs. But they end up looking just like NFD logs or NLSR logs in general. Basically what I'm saying is there's no special data collection functionality built into MiniNDN.
Okay, one more check mark.
Yeah, right. So, does anybody have any questions? It's hard to do a real live coding with this. We could show you is anybody interested in seeing us run this topology and maybe write a little experiment? And okay, yeah, okay, cool. So, yeah, I think what we'll do is we'll write some sort of small experiment here. So we've got our topology, which is a very simple two-node. Just imagine C and D aren't here, so it's as simple as you can get it. So I think so. What should we write? I don't know. What should we write for our little quick experiment here?
That is very fast and real-time code.
It's extremely fast.
So basically what we are doing is that we are rewriting our own run function. So in this experiment, node A will ping, node B will ping node A, and MinNet has this net object. So it's an array of object and it contains all the hosts. So So we are getting the each host from here.
Yeah, and the way that you specify a command to be run as that node is very simply the node name that you get out of there and then .command. So we've done that for convenience, but you can access the entire network is given by this .net member variable under the self in the experiment. So, and as you can see, we're running the ping server on node A and throwing away the output because we're not really interested in seeing it on the terminal. And then we're running a ping for 10 count to that prefix we just set up on the other node. And note that's on node B. And then at the end, this line here is what you have to do so that MiniNDN will know about it when it runs. So it's just experiment.register, and you give it an experiment name, and then you have to give the class. So our class is custom experiment, which inherits from experiment. And that's just sort of boilerplate for each experiment that you write. And what that allows you to do, that line there allows you, when you type, when you access MiniNDN on the command line, it'll show you the available experiments, and that's so you know that it's there, or that others know that it's there.
And this is the name you're going to use when you run MiniNDN and specify that
Yeah.
which. So this is the name you're going to use.
So why don't we show that? Actually show it being installed.
So we need to show. We need to save this file under the experiment.
Yeah, so the typical way that you would save an experiment is you go back into the MiniNDN source tree and you save it in the experiments folder, and then when you do that, you will rerun the install script, but you install only the new experiments, and all that does is actually copy over all the miscellaneous bits. So
Actually, I'm not sure why you're doing this, because when I played with MiniNet, not MiniNDN, you just write you install MiniNet to whatever Python wants that MiniNet to exist, and you just run the experiments like from whatever folder you put your experiment.
You can do it that way too, but I don't think that it will show up on the command line. I don't think it will bash autocomplete if you do it that way. But if you install them, if you put them back into the source tree and then rerun the script, it re-registers everything so that it knows it's aware of the new experiments. But you can just specify the experiment file directly on the command line. You don't have to go through this. This is just a sort of quality of life thing, so you don't have to remember where you keep your files. It's sort of like putting them into your executables path. Or it's analogous to. So yeah, let's just.
So yeah, this is so right now, so we'll be using this topology. So you can specify the name of the topology here, and then -- experiment, and then the name of the experiment.
Do you want to just give an absolute path to it? Because I don't think you've reinstalled it, did you?
No, I did not.
Yeah, so then just give the absolute path to the experiment file.
So yeah, if you you can reinstall it.
It's just -i, yeah. So basically all this does is it copies over all of the various utilities, and we could probably do some work to make it a little bit more convenient, but I don't know if you can catch it on there, but part of what this does is copies the experiments into, I think, user local etc or something. So if you are so inclined, you could just copy the experiments directly there, and then you would achieve the same effect. But generally, this is how we do it, just to each his own.
So now right now you should be able to see the name of the experiment here.
Yeah, so now you've seen that it shows up here when we actually run MiniNDN and we ask it to tell us which experiments we've got, and you see the one that we have custom, that shows up there as well. And so now we can actually run that one without giving an absolute path. We can just run MiniNDN, then our topology file, and then -- experiment, and then custom. So it's going to wait a minute to let everything converge, which is generally not necessary on this topology, but you can also specify how, like I said earlier, you can specify how long you want MiniNDN to wait before actually running your experiment. So you don't necessarily need to wait 60 seconds here. So while we're waiting, does anybody have any questions that I can answer to fill the gap?
So remember we talked about not starting all the routers exactly at the same time. I guess you haven't done that update yet?
No, generally we do start them all at the same time, so it can, if you have timing problems or...
I mean, usually like in real life, you don't start 100 routers at exactly the time point, which can have like some dramatic effects, especially on chronosync.
That's a good point. Yeah, we haven't investigated it. We've been working on incorporating some other features, so it's sort of fallen to the wayside. But yeah, it's pretty easy to extend since it's all Python. It's not too much. You can, if you're inclined to, you can add a wait time in between them, but that of course extends the amount of time that it will take to actually get running because it has to wait between each of the routers starting up.
Can you schedule some event like at some particular point of time? Or this has to be done with sleeps and...
There's nothing in MiniNDN to do it, but if you can get a Python library, it should just work, just any generic Python scheduler. It's pretty simply just some Python with that makes calls to the underlying system to launch NFD and stuff like that. So anything you can do in Python, you can set on top of this. And in writing the integration test for the auto prefix propagation that I mentioned earlier, I incorporated a bunch of other Unix command line tools to get the job done. So it's pretty flexible. If you're inclined to write some Python, you can do more or less anything you need to.
And maybe another random question. So I know testbeds like Emulab, Deter, they use some form of NS2 script to define topology and define the actual experiment with some syntax to schedule events at specific points of time. Does I would say MiniNet, given we're based on that, anybody is working on that? Are you aware?
I'm not sure. I know that one of the main concerns with MiniNet, like one of their main goals, is a sort of simplicity and scalability. So I don't know if they're looking to expand it. I know that we aren't looking to extend it in that way, but I don't know. It seems MiniNet's development has sort of tailed off. So we've even submitted a couple things back upstream in our development. So it's not something that we're generally considering, but if people asked about it, it would be something we'd look at extending because this is sort of our offering to the NDN suite of tools.
For evaluations of applications, it's very important to kind of pace out starting of the applications, then start some producer at some point, kill producer at the other point of time. So it would be very good if we have some convenient way of defining that scenario versus you have to write a Python script to figure out how to do with like.
Yeah. In general, if you need that level of granularity, we usually suggest that people use NDN sim for that. Recently, NLSR was ported, so they are mostly interchangeable. Not in terms of configuration, but in terms of what they accomplish. So in general, if you need that level of granularity, we point people to NDN sim because it's much more full-featured and you can collect metrics about everything since the entire network is simulated rather than emulated. So you get much more control over what happens and when it happens, and it's a much more involved network simulation tool than MiniNDN is. This is more intended for quick and dirty tests just to see how things look. But if you need a more in-depth sort of network metrics, it's probably better to use something like NDN sim for that. Yeah, so if we're not going to wait the full 60 seconds again, we're going to go ahead and see if we can't get this extremely complicated topology to converge in less than a quarter of the time. So -- C time equals, and then the amount of time in seconds. So let's try 15 and see if that works. So it'll show you after it's set up the network that it's going to wait for probably 15 seconds.
Is there an option to set up like manual topology, or like also pre-computed, but by some outside NLSR, or it's kind of an LSR is an essential part of, well, built in and always required.
Yeah, so since it was developed as an in-house tool to test how NLSR works, it generally uses NLSR, but you could, if you wanted, just delete a couple lines and then supply your own topology files by way of NFD configurations and stuff. But no, there's not currently an option on the command line to disable NLSR. Problem?
Yeah, still not there.
Well, you also haven't run the file.
No, just run it.
Oh, see, okay, so in this case, 15 seconds wasn't enough time. Turns out this is a very complicated topology, so I think after maybe 30 seconds. See, and this is actually part of what we do with MiniNDN. It can be difficult to anticipate what effects different applications will have on the network, so it can take a little bit of experimentation to adjust how much time you give the network to converge. And if I'm not mistaken, specifying the convergence time carries over. So like in that most connected node failure, it will wait that amount of time again. So if you give it 200 seconds on startup, when it fails that node and then recovers it, it will wait another 200 seconds to let the network converge again. So it does take a little bit of time to sort of sleuth it out, how much time that your particular topology might need to get a successful convergence. If you've got a 50-60 node topology, you might need to increase the convergence time to 2 minutes, 3 minutes maybe, depending on the specs of your computer. Did it converge?
Yeah, I did converge.
Okay. So then try just to cap the file. Or yeah, just list it here. But what's the present working directory?
It should be here, right? Experiment.
No, go back over to the terminal and then just type present pwd. No, not cat, just pwd. So you're not in the right directory, Alvi. You gotta go to the temp folder. Then B. Yeah, okay, so cat that file. Yeah, so after some bug fixing, you can see this is the result of pinging the node A. B was pinging node A using a ping server that was set up in the experiment file that we showed, and this is the output that we've captured from the terminal. And like I said, that's generally how you would want to collect how the information is to pipe it around to whatever scripts that you want. And MiniNDN doesn't provide any kind of output parsing or anything like that. So. And you can actually see there right at the beginning it still hadn't fully sorted itself out. So there was actually one of the pings did get lost before the ping server's prefix announcement propagated across the network. So, but you can see there's a good explanation or good illustration, I mean, of the link definitions. Because it certainly did not take 22 whole milliseconds to get from one virtual interface to the other, but we did define that there was a delay on the virtual interfaces, so that is reflective in the actual applications.
Actually, the first one, you send interest to that node, but that node didn't have application running yet.
Right, because yeah, and that's true. So you may need to adjust your experiment files to make sure everything is staggered in a way that you don't have this problem.
And to clarify one thing, what type of faces are used between nodes? Are they directly Ethernet faces or
Ethernet? I think they're Ethernet UDP simulating. Aren't they? Wait,
Yeah.
I'm not sure, are they actually? Let me have a look.
I think those should be specified in an LSR config.
Yeah, they probably are. Just go check one of the configurations and see what it says.
Yeah,
Because
it's
I'm not sure.
You're right, like UDP.
Yeah. So they're simulating UDP phases. So tunnel check another checkbox. Yeah, to simulate direct Ethernet. Yeah, but I don't think NLSR supports direct Ethernet faces. So
It should be exactly the same as UDP, like in the new release that we're gonna have. We're gonna have unicast Ethernet faces, and it would be exactly the same syntax to create. So instead of the only difference, you don't need to install IP stack at all or configure. Just use the Ethernet addresses.
But the implementation of NLSR is somewhat entangled, so it might take a little, especially the. No, I'm not sure just the particulars. Yeah, I'm not sure. I just have this vague feeling that there's something that would have to be addressed there, but I'm not 100% on that. So, but that shouldn't be too much work. I mean, all of these, it's just a sort of accumulation of small things. In general, unless we've needed it, it hasn't been developed. Mostly because there's not much outside adoption of this tool. So we're basically going off necessity for ourselves. But if somebody kept knocking on the door demanding support for Ethernet simulation, we would probably write that in there. So any questions? I mean, you saw us at lightning speed write an experiment file and install it and get everything running. And we've seen the output from that experiment that we wrote, but you can very easily imagine writing something much more complicated and doing a little bit more data crunching with the outputs to get some kind of...
Okay, so you flip into that page. That is it just a page for MiniNDN GitHub README repository, or is it a tutorial page?
Do we have tutorials? I'm not sure. We do have some. Ashlesh, the main developer, has recorded a couple videos walking you through. So if our yammering on wasn't explanatory enough, he has some videos that have been published to go through basically what we've done here in a more concise format. So we do have a kind of a brief page that describes how to create the experiments and everything. We've got these. Basically, what we've said here has been recorded in a couple different ways: in video format, in this tutorial format, and then occasionally we go to location to give this same talk.
And the page is linked from a name data website.
I'm not sure.
We it was recently developed.
Yeah, we only recently got this page up, so it's probably not there, but we can get it up there pretty quickly. Yeah, so if you go to namedata.net, there's a little link there to MiniNDN, but at this point, I think that only points to the GitHub. Yeah, currently that points to just the GitHub page that we've already showed you, but that link will be updated shortly to point to the more detailed MiniNDN.memphis.edu link. So we also have a mailing list. It's extremely low volume, so you don't need to be worried about being spammed, but there is a mailing list that stuff does get very occasionally published to, and you can send mails to if you have any questions that are particular to MiniNDN. So, and that's also on this MiniNDN page, I think. It's not hosted on the typical NDN mailing lists, so yeah. So there is it is. How about that?
There you go.
Yeah, so the MiniNDN mailing list is listed with all the other ones, so you can join that just like the other ones.
Okay, any other questions? Because we're like cutting close to the break.
Because I know I've bored you all to tears, but...
Are the namespacing and containerization capabilities in MiniNet getting any, I mean, it doesn't really matter kind of about the topic, but are they getting any better lately?
Yeah, it's
Especially the file system namespacing.
yeah. That was one particular problem we had. Part of the MiniNet having root access is that there are some situations that we had to address where you might indirectly delete the whole file system.
Yeah.
But I think these are quirks of MiniNet, and there's not much we can do about them without kind of contributing back upstream. Yeah, it's a bit of a problem because it's like I said earlier, development on MiniNet seems to have slowed somewhat in the years. Yeah, we don't really have. We showed you pretty much every single thing we could. So if you guys don't have any more questions, then I think we're done.